All right, for part D, we want y equal h of x to be a particular solution given that h of 0 is 2, and we want to use Euler's method starting at x equals 0 with two steps of equal size to approximate h of 1. And so there are two ways I can do this. One way is just sort of starting with what we have and using these sort of increments and differentials to figure out how much to make each step and change it that way. The second way is going to be to create full tangent lines or linear approximations and do it that way. I'll also show the shorter method first. For those that like that, you can stop there. And then I'll show the tangent lines if you want to see that next. So in here, we know that in general, the next f value, so for the n plus first x, is going to equal, or sorry, not equal, but be approximately the current f value, so the nth x value, and then we need to add on the change, so plus f prime of x sub n times the change in x. So this is approximately change in y over change in x, or change in f over change in x. This is change in x, so this will be approximately the change in y, or f, I guess. And so we have our current f value plus the change in f value gets me my next f value. And I can just go through this process and say, okay, so I know that f of 0 equals 2, which gives me the point 0, 2. I want to get to 1 in two steps. So I'm going to go from 0 up to 1. I'm taking an overall step of 1 in two smaller steps. So each individual step is going to have size 1/2. So go from 0 to 1/2 to 1. So I will find approximately what f of 1/2 is. And that's going to be approximately what f of 0 was plus f prime of 0 times the change in x. Well, f of 0, we're told, is 2. F prime of 0, well, I put 0, 2 into this. 0 squared is 0. Negative 1/2 times 2 is negative 1. And delta x, well, each step is 1/2. So I multiply that by 1/2. And this gives me 2 minus 1/2, which is going to be 3/2. So I'm at this point 1/2, 3/2 approximately. And then I take another step. So I went from 0 to 1/2. Now I'm going to go from 1/2 to 1. So f of 1 is approximately f of 1/2 plus f prime of 1/2 times that change in x. F of 1/2, we said was approximately 3/2. F prime of 1/2, well, I put 1/2 and 3/2 into this. So let me do that a little bit carefully. I'll change colors on us for a second. I'll go to red. So this means that dy dx will equal, we have 1/2 squared, which is 1/4, minus 1/2 times 3/2, which would be minus 3/4. 1/4 minus 3/4 is negative 2/4, which equals negative 1/2. So that's going to be the slope. So f prime of 1/2 is approximately negative 1/2, and the delta x is still 1/2. Negative 1/2 times 1/2 is negative 1/4. 3/2 is the same as 6/4. And so that's going to be approximately 5/4. Now, the other way. So if you don't remember how to do this to get the next value, you can always just form these linear approximations. So I could say, okay, I know that I currently have the point 0, 2, and the slope is going to be, and I put 0 and 2 in here, 0 squared is 0, negative 1/2 times 2 is negative 1/2, or sorry, negative 1/2 times 2 is negative 1, and I'll make a little tangent line. I'll call this my first tangent line, L1 of x is going to be negative 1, x minus 0 plus 2, or you can do negative 1x plus 2, and I'll evaluate this at 1/2 to get to my next x value. And I'll get negative 1 times 1/2 minus 0, which is going to be 1/2, plus 2, and lo and behold, we get the same output here. Negative 1 times 1/2 is negative 1/2, plus 2 is 3/2. And then I can go ahead and say, okay, so I have the point 1/2, 3/2, it's just an approximate, and I put this in here to get my slope. And I get 1/2 squared is 1/4. Negative 1/2 times 3/2 is negative 3/4. 1/4 minus 3/4 is negative 2/4. Reduce that down, negative 1/2. Very familiar because we're really doing the same work we did here. It's just a little bit of extra stuff, but it might be clearer. So I make another tangent line, L2, and that's going to be negative 1/2 x minus 1/2 plus 3/2, and I evaluate that at my next x value, which is 1, so I get negative 1/2. 1 minus 1/2 is 1/2. Negative 1/2 plus 1/2, or sorry, times 1/2 is negative 1/4. 3/2 is the same as 6/4. Negative 1/4 plus 6/4 is 5/4. So this is a little bit extra work. I skipped some more steps doing this, but they'll both work to get your answer.